welcome back to my channel, and today we're going to be talking about three main forms for quadratics in algebra. So we have the first form, standard form, second form, vertex form, third form, intercept form. So to start off, we have standard form, and the parent function for all these functions, by the way, is f of x equals x squared. So to clear thing one up, we have x equals 1, we plug that in for x, that's just, x, and then we have, when we solve for y, which is f of x, so 1 squared is 1, so f of x equals 1, so our point would be 1 comma 1, just to clear that up. So we have standard form, and so let's read this from left to right. So we have y equals ax squared plus bx plus c. So a is our vertical stretch slash shrink. So let's say we had an a value of 2. So that means we have a stretch, and the reason for that is a stretch is anything for a which is greater than 1 per se. So a is greater than 1. So let's clear one thing up. So when a is negative, when a equals a negative, like we have a negative value for a, that means that our parabolic function is reflected across the x-axis. So let's say we had a parabola like this. If our a value was negative, it would go like this. And so yeah, so it would go like that from the vertex, not just from, the x-axis. So yeah, so if we had an a value of, say, -2, it would be reflected, but it would still have a stretch of 2. And a stretch is usually narrower, so the graph would be narrower than the original parent function, which is f of x equals x squared, which has an a value of 1. But, a obviously isn't there, so it's just 1. So when a value is greater than 1, that means that just the parabola is narrower. And so if it's less than 1 but greater than 0, then it's a shrink. So a shrink is a is greater than 0, but at the same time a is less than 1. So it's a shrink. An example of a shrink would be 1/2. So 1/2 or maybe 1/4. So same rule applies. When we have a negative here, it's still a shrink of 1/4, but it's just reflected. It's just turned upside down. So now that we know that, let's move on. We have b. And so b is helpful for finding the vertex, which we will talk about right now. So to find the vertex, which is the starting point of any parabola, we have to find the values. So to find the x value of the vertex, we have a little formula right here, which I've already written down, which is negative b over 2a. So when you plug values in, so let's write an equation right here. Let's write y equals 2x squared plus 20x plus 42. So let's see, we have a value of 2 and we have a b value of 20. So to find our x value of the vertex, we basically just have to do negative b over 2a. So we have 20 for b, so we plug negative 20 in here over 2, and then whatever our a value is, and that's 2. So into 2 that's negative 20 over 4, and that just comes down to negative 5. And so our x value for the vertex would be negative 5. And our x value of the vertex is more commonly known as the axis of symmetry, which you can also abbreviate as AOS. So axis of symmetry is when the parabola reflects itself. So when it goes from down to up, basically. So our AOS in this case would be x equals -5. Now it's important that you write x equals -5 and not just -5, because our axis of symmetry is a line. and it's a line which has a value for x. So it has to be written in the form x equals -5. So we have our axis of symmetry. So now you're thinking, how do we find the y value then? We simply just plug in our values back in. Since we already have our x value here, we just plug it back in to 2x squared plus 20x plus 42. So we can just simply write as y equals 2 into -5 whole square plus 20 into -5 plus 42. And so we have -5 the whole square in parentheses, and so -5 into -5, since this has parentheses around it, would be 25 into 2, which is 50. And then 50 plus, so 20 into -5, which is obviously -100. So let's erase this minus, we have plus right here, -100 plus 42. And so that just comes out to be equals -8. So our vertex would be -5 comma -8. So that would be our vertex. So we have our vertex, and that's how you get it from a standard form equation. So when you plot a parabolic function, which you can find in my other video, you basically graph the vertex, and then when you have the vertex, you can either take the y-intercept of the graph, which is c, and then you can take the roots, or you can basically just cross all this out, and except for a, just cross all this out, and then you would have ax squared, and then you can just graph from the vertex, but you can see that in my other video. So that's how you use standard form when graphing. And so moving on to vertex form, we have the form y equals a into x minus h to the whole square plus k. So how we go about this is, the reason it's called vertex form is it's already giving us the vertex. And our vertex is h comma k. So let me simplify that. So h comma k, in this case, we have minus h squared whole square plus k. Now, let's say we had an equation like y equals -1/4 into x plus 3 whole square plus 4. So we have -1/4 for a, and so in all these equations right here, a will always be the stretch or shrink. That just doesn't change. A will always be the stretch or shrink. So I have a shrink of 1/4, and it is reflected. So moving on, we have x plus 3 the whole square. So if we look at our original equation, we have x minus h to the whole square plus k, and we have x plus 3 here. So how did this minus turn into a plus? Well, the only way possible for that is there had to have been another minus for h. So that meant that our h value had to be minus, meaning that it would be -3. So basically for h, you can think that when you have a value here and it's positive, it's just the inverse of the original equation. So if it was positive here, then h would be negative. If it was negative here, h would be positive. You can think of it like that. And then we have +4 right here, which would obviously just be +4 because we have plus k right here. But if it was -4 right here, we'd write -4. So we put parentheses around that, and that's our vertex. And that's why they call it vertex form, because it's really easy to get that vertex. Now, moving on, we have our vertex. And I'm thinking, how do we graph this? Well, we could simply just plot the vertex, and then we just get rid of all the values right here. And then we have a into x squared right here. And then that we can just, whatever value for a, we plug in for x, and then we get the value for y. And that's how you graph. And so that's pretty much all you need to know for vertex. So you have H and K, and just to be clear, H is your horizontal shift from the origin and K is your vertical shift. So when you're writing transformations, you would say horizontal shift if there is one, and vertical shift if there is one. So we're moving on, we have intercept form. So intercept form is written in the form y equals a into x minus p into x minus q. So the reason intercept form is useful is because it gives us a solution. It gives us our solutions right in front of us to pretty much almost simplified. So thinking back, when we have a solution for a parabolic function, it would the solution would be the roots or the zeros. And so the zeros are the x-intercepts. And so the x-intercepts here would be whatever value for x right here. And so whatever our value for x right here, we can just say that's the zeros. And so let's write a intercept form equation. So we have f of x equals 2/3 into x plus 8 into x minus 5. So we have this intercept form equation right here. So our a value, of course, stays the same. It's 2/3, so we have a shrink of 2/3. And we have x plus 8 and x minus 5. So our roots or solutions would be x plus 8 equals 0 and x minus 5 equals 0. So how we solve for x is very simple. We just subtract and isolate for x. So x in this case would equal minus 8 and x would equal plus 5. So that would be our solutions. And so that's the really great thing about vertex form. Intercept form. Because we pretty much have our solutions right in front of us. So now you're thinking, how do we graph this? Well, when we're graphing, we usually can use roots to graph because there are 2 points that are given to us, which are the roots. And then every graph always has solutions, well, most of the time. So our solutions are already given to us, so we can just graph them. Now you're thinking, how do we find the vertex? Well, that's also pretty easy because our vertex, so our roots, one thing I forgot to mention. So the vertex is in the middle of the 2 roots, or the axis of symmetry. So the x value of the vertex is in the middle of the 2 roots. So we know our roots are minus 8 and 5. So we can write minus 8 plus 5 over 2, which is minus 3 over 2. So our x value would be minus negative 1.5. And then so when we have that value for x, we can plug it back into the original equation. So negative 1.5 right here. And then we just simplify it. So once we plug in that, and then we just simplify it. So we simplify the parentheses and then we multiply everything by 2/3. And yeah, that's how you get the vertex. So yeah, that's pretty much all you need to know for intercept form when you're graphing, vertex form, and standard form. And yeah, I hope this video helped.